Hello, I'm Kirk Weiler, and this is Common Core Algebra 2 by eMath Instruction. Today, we'll be doing Unit 7, Lesson number 1, on shifting functions. Unit 7, in general, is all about the transformations of functions, how we move them, also known as translate them, how we reflect them or flip them across the y and the x-axis, and how we stretch them both vertically and horizontally. Today, we're going to be pretty much looking at something that is mostly review for you, which is how to shift or translate functions right, left, and up, down. So let's jump right into that with the absolute value function. All right, in exercise number 1, it says consider the functions y equals the absolute value of x, y equals the absolute value of quantity x minus 3 plus 2, and y equals absolute value of the quantity x plus 1 minus 4. In letter A, it says, without the use of your calculator, graph y equals absolute value of x on the axes provided. Now, the reason we should be able to easily do that without our calculator is because we should be able to set up a real simple table of values, right? I mean, this graph paper, goes to -6? But if we take the absolute value of -6, we get +6. So we get the point 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6. Right? We get something that looks like that. And then if I come over here and I do -5, I get 5, right? Which gives me this point. And then -4, I get 4, which gives me this point, etc., right? And in fact, then I get that classic graph that I should know oh so well, the absolute value graph, which essentially looks like a V. Very nice. Maybe I'll draw the straight lines in with my straight line constructor. And just so I don't lose any points on an exam, I'll put some arrows on the end. All right. Y equals absolute value of x. Now, letter B says, using your calculator to generate a table of values, graph the other two absolute value functions above and label each with its equation. I'm not going to open up the TI-84 Plus right now because we've shown you many, many times how to create a table on your calculator. What I'd like you to do is pause the video now and create graphs of both of the other two functions. Make sure to label their equations so we know which one's which, and then we'll go through them. All right? All right, let's go through it. Okay, for, let's say, y equals absolute value of x minus 3 plus 2, I'm going to do that in red. Let me just verify. Yep. Okay, it kind of looks like this. These are all the points that we can actually fit on it. For some reason, I chose not to use my straight line grapher there. And the results are obvious. Not really the point, though. And let's go with one last color. Let's go with green on this one. Okay. And what we end up having there are these points. Once we generate our table of values, we'll go back to what worked the first time, and we get this graph. And let's add some arrows and a label. Now, the point that we're supposed to be seeing here are our shifting patterns, right? So let's just take a look at x minus 3 plus 2, right? This function is based on the simpler y equals absolute value of x function. But y equals absolute value of x has been shifted. How? It's been shifted to the right 3 and up 2. To the right 3, and up 2. I know the problem didn't ask us to specifically do this, but, right, the whole point is to see these patterns. On the other hand, when we had y equals the absolute value of x plus 1 minus 4, notice what happened there, shifted 1 to the left and 4 down. So y equals the absolute value of x went to the left 1 and down 4. Left 1, down 4. All right? So based on all of this, how would the graph of y equals absolute value of x be shifted in order to produce the graph of y equals absolute value of x minus 6 minus 8? Notice you don't have to graph it. Our graph paper is perfectly full. But pause the video now and tell me how you would have to shift y equals absolute value of x to get y equals absolute value of x minus 6 minus 8. Pause the video now. All right, so we would have to shift 6. Okay, well that was weird. Sorry. Shift 6 to the right. Oh, man, all sorts of things going wrong today. Shift 6 to the right and 8 down. Right? And again, we're going to explore a little bit later on in this lesson that counterintuitive horizontal shift and why subtracting shifts to the right and adding shifts to the left. Thankfully, when we do something overall to the function, right, then it shifts it up, down, right? When we add or subtract overall, it shifts it up or down the way that we would think it would. So subtracting 8 takes that absolute value function and it shifts it down, whereas subtracting 6 directly from x shifts it to the right 6. All right, pause the video now and write down anything you have to. Okay, let's clear out the text. It's gone. Let's summarize. Vertical and horizontal shifting. The vertical shifting is the easiest of them because if we take f of x and we add k, then it's going to shift it up by the absolute value of k when k is greater than 0 and shift it down k units for k less than 0. In other words, when we add a positive number, it's going to shift the function up, and when we subtract a positive number, it's going to shift the function down. On the other hand, when we add or subtract directly to the x variable, it goes counterintuitive to what you'd think. Adding directly to the x variable, a positive number, shifts it left, whereas subtracting shifts it right. Okay? Now, to make sure that we have this, let's do a little exercise right on this page. So here we've got a very abstract function. It's just kind of graphed on our graph grid. It says a function f of x is shown on the grid below. A second function g is defined using this rule. Remember, this isn't something that's all that abstract. This is the function's rule, right? And the first thing that they ask us to do is just to figure out the value of g of 0. Show how you arrived at your answer. All right, well, pause the video now and see if you can come up with a value for g of 0. Okay, well, whenever we are given a function and asked for an output, we should just follow the function rule. So g of 0 will be f of 0 minus 3 plus 1, which is f of negative 3 plus 1. But then the question is, what's f of negative 3? Well, we're going to be doing this a lot today. F of negative 3, since this is the function f of x, f of negative 3 is equal to 1. So we just get 1 plus 1, which is 2. Now think about that for a minute. That means that the point 0, 2 must lie on the graph of g, right? Versus the point negative 3, 1, which lies on the graph of f. Now the question asks us to identify how the graph of f, that one that's sitting there, has been transformed to produce the graph of g, and then we should sketch it on the grid. Well, according to our vertical and horizontal shifting patterns, what we know is that because we've subtracted 3 directly from the right, subtracted 3 directly from x, it's been shifted 3 units to the right and shifted 1 unit up. Now, the easiest way then to graph it really is to take sort of primary points, if you will. I would take these 4 primary points, and I'm going to shift it 3 units to the right and 1 unit up. Maybe I'll do this in a different color. So 3 units to the right, 1 unit up. 3 units to the, I could do that point. Actually, let me do it. 3 units to the right, 1 unit up. 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 No real need to actually put this point on here, but I did actually want to have that because that's the point 0, 2. That's this guy, right? Let me draw in the rest of the graph. And there it is. Translations, right, are what are called rigid motions in Common Core geometry. Your teacher may have also called them isometries because that's another name we know them by. They don't change the shape or the size of the figure at all. They just shift them right, left, and up, down, right? In geometry, we would have called this a translation, right? And actually, it would have been given the following symbolism. Let me put this back in blue. We would have said, translation 3, 1. Many teachers use this notation for translation. Anyway, just some connections there with Common Core geometry. Anyhow, pause the video now, write down anything you need to, and then we're going to keep working with these shifting patterns. Okay, I'm going to clear it out. Let's keep going. All right, exercise number 3. A function f of x has a domain, x greater than or equal to -3, less than or equal to 10, and a range, y less than or equal to 22. What are the domain and range of the function f of x plus 7 plus 10? Explain how you arrived at your answers. Well, what I'd like you to do is I'd like you to think about this a little bit. Just take a little bit of time, pause the video, and see if you can come up with the domain and the range of our new function. Okay. I always kind of think of domain and range as being a box within which the function lives. So the function sort of, if you will, lives between -3 and 10 horizontally, right? And then it lives from 22 down vertically, right? That's that. But f of x plus 7 plus 10 is f of x shifted 7 left, right? That's this part, and 10 up. That's this part. Therefore, we should be able to take this box and shift it 7 to the left and 10 up. Now, what happens when we shift all of this 7 units to the left? Well, the -3 will become -10. And the +10 will go all the way down to 3, right? All I'm doing is subtracting. On the other hand, when we take this and we shift it 10 units up, it's going to be now up there at 32. So our new domain is going to be -10 less than or equal to x less than or equal to 3, and our new range is going to be y less than or equal to 32. So if you got those two, then you're really starting to process these shifting patterns, right? Especially in these particularly abstract forms, when this is the only formula that we're given. So if you're doing that so far, if you got that as your domain and range, well done, well done. All right, pause the video now and write down whatever you need to. Okay, I'm going to clear out the text. All right, exercise 4. Given the quadratic function, all right, we're back to quadratics, f of x equals x minus 4 squared minus 5, answer the following questions. I think you can actually probably do letter A and letter B. You might even be able to do this whole problem on your own. So try letter A and B. Pause the video, read both of those questions, and then try to answer them. All right, well, the function that we're looking at, this guy, is based on the exceptionally simple function y equals x squared. So they ask us, how has that been shifted? Well, it's been shifted 4 to the right and 5 down. Oh, let me take this moment, though, to make sure that you don't do something that's very, very common. I'm going to write it in red and then we'll cross it out. A lot of students, when they talk about the horizontal, especially if it's going to the right, we'll say something like 4 over, okay? You don't want to do that because what does over mean? Does it mean to the right? Does it mean to the left? I don't know. But if your instinct here is to say, oh, it's moved 4 over and 5 down, well, then that's a problem because 4 over really doesn't mean much. Now, letter B, it says, given that y equals x squared, right, this guy, has a turning point at 0, 0, where must the turning point of f lie? Well, the whole point is that every point on this function is going to be translated 4 to the right and 5 down. And therefore, it must have a turning point at 4, negative 5. That's why this is called the vertex form of a parabola. And I know we've already talked about that, but it really makes sense to hammer home the point now. Now, letter C says, sketch f below and give the domain interval over which f is increasing, Well, we can easily sketch f now. I mean, maybe it's not going to be the greatest sketch on earth, but it's going to be pretty good because I know where its turning point is. Its turning point is at 4, negative 5. Maybe put that right there. And then I know it's a concave up parabola, a parabola that opens upward. So it kind of looks something like this. Maybe not the most beautiful thing, but whatever. Now, the domain interval, right, the x interval, over which this is increasing. Well, remember, what I want to do is I want to walk from left to right along this curve, and I want to talk about where it's going uphill. And there's two really acceptable answers here. You can either say x is greater than 4, that's a great answer, or you can say x is greater than or equal to 4. That's a good answer too. Either one of those, okay? Include the bottom of the hill, don't include the bottom of the hill. Letter D, which has a lower minimum value, the function f, right, the one we've been talking about, or the function g of x equals absolute value of x minus 6 minus 10? Explain your choice. Again, pause the video now and think about this a bit. All right. Well, we already know the minimum for f, so I'm going to write down f minimum is negative 5, right? That is the lowest y value on this function. The question is, what's g minimum, right? Well, we should be able to look at this function and know that that is the absolute value graph that has been shifted 6 units right and 10 units down. So it looks something like this, right? With its turning point at 6, negative 10. Therefore, g minimum, I can get rid of this question mark now, g minimum is negative 10. Therefore, g of x has the lower minimum. All right, and that really gets at why we learn about shifting. We learn about shifting so that we can look at a more complicated function, like that function g that we just saw, and very quickly be able to produce a sketch of it without our calculators, without any kind of technology, without having to draw out a table of values, and we can very quickly get a sense for where its turning point is, what its minimum is, where it's increasing, decreasing, etc. All right, pause the video now and write down anything you need to. Okay, clear out the text. All right, let's take a look at one last exercise. And in this last exercise, I want to give you at least a little feeling for why it is that subtracting from x shifts to the right, and by extension adding to x shifts to the left. So in this problem, we've got the graph of f. Again, no equation or anything like that. And then we've got the function g, which is defined as f of x minus 2. Okay? Letter A says, show that x equals negative 1 and x equals 2 are zeros of the function g. All right? Well, what's a zero? Right, a zero is any x value that solves this equation, g of x equals 0. So to show that these two things are zeros, all I really have to do is evaluate. So let's evaluate g of negative 1. That's going to be f of negative 1 minus 2, and that's f of negative 3. All right? And f of negative 3 is 0. Now right away notice something, right? G's value at -1 is F's value at -3. So we literally took F, right? And if we shifted it 2 units to the right, we would then have the value that G has. Likewise, if we evaluate G of 2, that's going to be F of 2 minus 2, which is F of 0, and that's right here, and that's also 0. And again, take a look at that. G of 2 is going to be F of 0. So G has a value, the same value that F has, but 2 units to the right. Letter B says evaluate each of the following using the definition of G, then create a plot of G on the same set of axes. All right, what I'd like you to do is pause the video right now and evaluate each one of those values for G, create points, plot, and verify that this thing did move 2 units to the right. Okay, pause the video now and do that. Okay, let's take a look. Well, G of -3 is going to be F of -3 minus 2, which is going to be F of -5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. And that's -6. So that's going to be the point -3, -6. Let me graph it in red. And that's right here. And notice all we really did was we just took this point and we shifted it 2 units to the right. G of 0 will be F of 0 minus 2, which is F of -2, and F of -2 is right here, and that's going to be a +3. So the point 0, 3 is also on this graph. And again, all we really did was take this point and shift it to the right 2. Finally, G of 4 is going to be F of 4, F of 4 minus 2, which is F of 2, and that's -3. So we have the point 4, -3. And again, all we did was take this and shift it over. Let me complete the graph. And there it is, right? So counterintuitive though it is, when we subtract from the x variable in a function before we do anything else, it takes the original function or the more simple function and shifts it to the right. And likewise, adding shifts it to the left. All right, pause the video now and write down anything you need to. Okay, let's clear it on up. Okay, so today we looked at a topic that you've seen many times. Back in Common Core Algebra 1, probably a little bit in geometry, and we even saw it earlier this year when we were shifting parabolas and completing the square. Okay, but here we wanted to make sure that we could shift functions that weren't just parabolas, but that were absolute value functions or really any types at all. Okay, and we're going to see more shifting as this course goes on. For now, I'd like to thank you for joining me for another Common Core Algebra 2 lesson by eMath Instruction. My name is Kirk Weiler, and until next time, keep thinking and keep solving problems.